So here we go. We're going to continue on our notes from our notes from yesterday, and then we're going to do new stuff. But for the first part, so here you got a number in front of the variable. How do you solve this problem? Any suggestions? Henri? That is what you do. You do have to raise both sides, but we got to do something before we get there because this 2 in the front is really screwing things up. Jessica? Yeah, divide both sides by 2 first. Isolate the variable, exactly. And then you got y to the negative 1 equals 6. And now here's the interesting question. We got to raise both sides to the reciprocal. What's the reciprocal of negative 1? Negative 1. That's the weird thing. Because look, negative 1 is the same thing as negative 1 over 1. You know what I'm saying? And the reciprocal of that is just 1 over negative 1, which turns out to be negative 1 in the end. So it didn't really make a difference. Do you understand what I'm saying? And then we make it rain. You know what I mean? Yeah, make it rain. And so y to the first equals 6 to the negative 1. And y equals 1 over 6. And that's it. That's how we do. I'm just kidding. That's how we do it. All right. We got another one going on here. Another one. Take a minute. Let's try it, and then we'll reveal the answer. Here we go. So what's the first thing that we got to do? And how are we going to isolate the variable? Very nice. Yeah, we got to divide both sides by 9. That's what we do. Okay. And so then we get this. Right? We get a to the negative 3/4 equals a third divided by 9 is 1/27. Yep. It's like, yeah. It's like if you broke a third up into 9 pieces, how much would each piece be worth? It'd be worth a 27th. That was hardcore. Let's raise both sides up because we're going to get rid of that power. What are we going to raise both sides up by? 4 over negative 3. Doesn't really make a difference. It's the same thing as negative 4/3. So 4 over negative 3. And then you know what we do. We make it rain. Make it rain. This side, though, you don't actually have to do that. You could just punch this into your calculator, the right side. And so you get a equals, what's the answer? Yeah, a equals 81. Why is that weird? Oh, I can explain it to you. There's lots of operations going on here. The negative inside means direction. It's got to go the opposite direction. Instead of getting smaller, we flip it. It's 27 to the 4/3. The bottom number is the index, right? What's the cubed root of 27? 3. The top number is the exponent. So what's 3 to the 4th? That's how it got there. And here we go. Let's try this one. Have a go. Lauren? Let's pick a random person. Lauren, I'm just interested in the process. What would you do first? Good. And after you minus 7, then what would you do next? Good. Okay, so let's do this now really fast. It's not difficult. Did anybody get lost in the process that we were doing? Let's see. No, after this one, we're going to do new stuff. It's going to be awesome. Right? Come on. Divide both sides by 5. Divide both sides by 5. X to the 1/2 equals 3. Then we have to try and solve that, right? Let's raise both sides to the reciprocal of the exponent. Distribute that in. Jason, over. You do know that I am recording this, right? Take some notes. Stop messing around. Come on. Multiply that in. Drop it in. So that's x. So the first equals 3 squared is 9, and then we're done. There you go. So here we go. So our new topic of the day is we are going to be solving exponents with the same base. We're going to do one question like this, and then we're going to show you how to solve them when they have different bases. But the idea is really, really, really simple, right? Here's the deal. Look, these two things are equal to each other. The bases are equal to each other. So what must their exponential powers be? Their exponential powers must therefore be the same. So you see these two things highlighted in yellow? All you do is set them equal to each other and solve, and then you're done. It doesn't get any more difficult than this. I swear, I promise. For this one, at least. Divide by -1, divide by -1. X equals 2. And that's your final answer. You're done. Put a nice box around it. It's very clean and neat and organized. It's great. All right. All right. Jason Overton, you're taking excellent notes now. In any event, come on. Today, so we just solved equations that had the same base. Now we're going to solve equations that have different bases. And as you can see, there's a trick to them. You have to change them into the same base. What the hell do I mean? What do I mean? Well, let's take notes for a minute. Let's write all this down on your own paper, and then we're going to figure out what I'm talking about. All right, so here we go. How could you give them the same base? Any ideas? Patty? Nope. Nope. This one's hard. This one's hard. Cameron? Good, good, good. I'm just going to rephrase the way that you said that. I want you to rewrite this as something that has the same base as possibly 2. Turns out 8 can be rewritten like this. Isn't it worth just as much? It's of equal value. How did I know how to do that? Well, part of tomorrow is we're going to practice rewriting things in terms of equal expressions as powers. What? That's easy. Yeah. Now they're the same bottoms. They're the same bases. Yeah, x is going to be 2x equals 3. Divide both sides by 2. X equals 3 divided by 2. And another way that you could say that is 1.5. What? It's not working out anymore? It's too difficult? Yeah, this is easy. No, you don't have to write down both answers. You could have written one or the other. I just do this now because some people like to show their work in decimal form, and I want to give you a good way. I want to give you a good model to follow. So here we go. This is an example. So one thing I wanted to do is this is an easy problem, and this is a difficult problem. And then we're going to go back to easy again. I wanted to show you how deep and far the rabbit hole goes with this. Let me show you one way to do it. One way to do it, right? You take the original, equal to 0. No, we're going to do the same. We're going to do the same kind of stuff that we've been doing. Let's transform this decimal into a fraction. What's the matter? Is that what you're thinking? This is 4 over 100. That's also the same thing as saying, if you used your calculator, 1 over 25. And up, it's starting to move in the direction that we want it to go. Okay? Exactly. Because that bottom number, 25, that's just 5 squared. Yep. Now, how could you convert this so that they'd be on like the same level? You know what I mean? Dev? Very nice, yeah. So then 5x minus 1 equals 5 to the negative 2. And then we're back to the starting point that we began. Yep, x minus 1 equals negative 2. we're going to add 1 to both sides, equals -1. Let's play again. Let's play again. Let's play again. And so now, check it out. You're given 4 and you're given 8. And the problem is that 8 can't be expressed as a power of 4. But maybe they have something smaller that they both could be re-expressed using. Power of 2. Very nice. What is 4 as a power of 2? It's 2 squared. And then we have that x on the outside equals. And now 8. How could 8 be a power of 2? Good. That's how you do it. We're going to practice more about how you could rewrite things so you get used to it. Yeah, now watch. You know what we're going to do? We're going to make it rain. We're going to make it rain. And so then it becomes 2 to the 2x equals 2 to the 3x plus 3. Let's go big screen. This equals this. Yeah. 2x equals 3x plus 3. What's up? Nope. The 3 multiplies the x and the 3 multiplies the 1. They don't add. But good observation. I can make mistakes like that. Right? X equals -3. Last problem of the day. Felice, take us home. What do we do? Yeah, -3 from each side. Now here's the question. If you don't see a number up there, what is it? Good. Just set these two things equal to each other. You get x minus 1 equals 1. Yeah. That's it. That's all I got.